Okay, today's lesson is on rational exponents. If you look in the word rational, you can see the word ratio. A ratio is when you have a comparison of two numbers, and it can be written, if you recall, a ratio can be written like this. It can be written this way, using numbers usually, or it can be written as a fraction. And you say A to B all three ways. You say A to B, A to B, A to B. You say them all the same way. Okay. When we're doing exponents, we are going to be using the fraction form. Okay, so we're going to have fractions for our exponents. For some of them. Now we're going to start out with a review of what we've done the past couple of days. So these beginning ones are not going to be anything new. Okay, so find each of the following. Remember, we are not using a calculator. The square root of 9, a number times itself that is 9 would be what? 3. So put a 3 under here. Plus, the square root of 25 is 5. And then 3 plus 5 would be 8. Okay, let's look at another one. The square root of 100 is 10. Minus the square root of 16? 4. Remember, 8 times 8 is not 16. 4 times 4 is 16. And then 10 minus 4 is 6. Okay? Square root of 32 is not a perfect square, so we need to break it up. We need to find a perfect square that can divide into 32. Nicholas? 16 times 2. Good. So we're going to break this up into 16 times 2. Since the 16 is a perfect square, we can take the square root of 16. It comes out as a 4, and the 2 is left inside because that is not a perfect square. Okay, bring down your plus sign. The square root of 50 can break up into 25 times 2. The 25 is the perfect square. It comes out as a 5, and the 2 is left inside. Now the rule is, if they have the same number in the radical, then you keep that radical, and you can add or subtract the numbers that are in front. So 4 plus 5 would be 9. So 9 square root of 2. All right, the square root of 27. 27 is not a perfect square, so we break it apart into 9 times 3. The 9 comes out of the radical as a 3. The 3 is left inside, minus 48 can break apart into 16 times 3, good. You want to pick the largest perfect square. 4 goes into 48, but so does 16. You want to go with the largest one. 16 comes out as a 4, and the 3 is left inside. Now they both have a 3 in the radical, so we keep the 3, and we do 3 minus 4, which is negative 1, but we don't need to put the 1, we can just write negative, because we know if there's not a number in front of our radical that it's just 1. Okay? All right, so even though we have a lot of radicals here, you don't do this any different. You just have more to simplify. So 18 can break down into 9 times 2, which we rewrite as 3 square root of 2. Very good. Plus 45 breaks into 9 times 5, which we can rewrite as 3 square root of 5. Good. Plus the square root of 125 breaks apart into 5 times 25. The 25 comes out as a 5, and the other 5 is left inside. Bring down the plus sign. 8 breaks apart into 4 times 2. The 4 comes out as a 2, and the 2 is left inside. Okay, so what could we do at this point now? Kennedy?
Add up all the radicals.
Add up what?
The radicals?
All of them?
No, 2 of them at a time.
Okay, so which ones can we combine?
So 3 square root of 5 and 5 square root of 5.
Okay, so the 3 square root of 5 and the positive 5 square root of 5 would be 8 square root of 5, right?
Yeah.
Okay, and then we could combine the 3 square root of 2 and the 2 square root of 2 because they both have a square root of 2, and that would be plus 5 square root of 2. Very good. Okay? All right, square root of 40 can break apart into 4 times 10. Good. You should start to be getting quicker at pulling out the perfect squares. All right, the 4 comes out as a 2. The 10 is left inside. Okay, plus, how about square root of 54?
9 times 5.
9 times 6. The 9 comes out as a 3, square root of 6. Minus, what's the 24 break apart into? 4 times 6, so that's rewritten as 2, square root of 6. Okay, now, the 2 square root of 10, we're just going to leave alone because there's nothing to combine it with. And then 3 minus 2 would be positive 1, right? So plus, we don't have to put the 1, we can just put square root of 6. Okay, now, this is where the new stuff jumps in. Okay, so be very patient as we go forward, and as we continue through the examples, you will get the hang of it. But this is new, so it's going to take a minute for it to kind of sink in and for you to kind of grasp a hold of it because we haven't had rational exponents before. Now, we have had square root of 9, which is what? 3. Okay, now let me show you something. If you know that with a whole number, if there is not an exponent shown, that there's a 1 there, right? You also should take note that when we have a square root, we know square root means to figure out a number times itself, right? So basically 2 numbers, 3 times 3 or 4 times 4, okay? So this is really a 2 right here. It's saying the square root, the second root of 9 to the first power, okay? Now we don't normally put that, it's just assumed square root meaning 2 numbers. If it's anything other than that, then we would have a 3 or a 4 or a 5 out there, okay? Kind of like with exponents. We know it's a 1. If it's anything other than 1, it would say 9 squared or 9 cubed or 9 to the 4th power, okay? So I want you to see how you can get from here to here because these are the same problem, okay? So what you would do is you would take 9 as your base number, and the exponent for the 9 is your numerator, and then whatever the root is your denominator. Okay? So that's just another way of writing square root of 9. 9 to the 1/2 power means square root of 9. It's the same thing. It's written in a different form. It's written having a rational exponent. You just need to get in the hang of seeing it differently. Okay, so 9 to the 1/2 power is still 3. It's still 3. It's just another way of writing square root of 9. Yes?
I forgot what you said about how you get to the 2 on the square root.
Well, if there's not a number in front of the radical here, or right here in this little spot, it's always a 2. Okay? So square root of 16 is what? 4. So you should be getting in the habit now of realizing, okay, if it's to the 1/2 power, that just means we're square rooting. Okay, so the square root of 16 to the 1/2 power is also 4. Okay, square root of 81 is 9. This is 81 to the 1/2 power because 81 to the 1/2 power, okay, which is 9. 100 to the 1/2 power, or square root of 100, is 10. Whoops. Thank you. 25 to the 1/2 power is 5.
So we're basically just reversing it?
Well, we're still doing square root. This is just another way of writing it as a rational exponent without the radical. So if you needed to write a number without a radical, it would have to have a rational exponent. Okay, so this one, this has an exponent of 1, right? So that, well, it didn't say for us to write this as having a rational exponent, excuse me. We are supposed to figure out what this is. This says the cube root of 27. Nicholas?
I know how to solve that.
You do know how to solve it? Okay.
You can make it from 27 to the 1/3 power, and then you put it to the 1/3 power, you divide it by 3 and get 9.
Well, you could write it as 27 to the 1/3 power. That would be another way of writing it. But the cube root means a number times itself again. So, and square root is a number times itself, right? Twice. Cube root means a number times itself again. So what times itself again would be 27? 3 times 3 is 9, times 3 again would be 27. So therefore, the cube root of 27 is just 3. So if we just have to figure out what the cube root of 27 is, we would write 3. If it said, rewrite this having a rational exponent, then we would write 27 to the 1/3 power. So it just depends on what the directions ask you to do. If they say rewrite it with a rational exponent, you do what we just talked about. The exponent's the numerator. The root is your denominator, and you would just leave it like that, okay? But if you're supposed to figure it out, it's what times itself again. Okay, so now if you look, that's exactly what's here, right? 27 to the 1/3 power means the cube root of 27, which we already figured out is 3. All right, the cube root of 8 would be 2. 2 times 2 times 2 is 8. So 2 is the answer. Or if it was written this way, 8 to the 1/3 power, the answer is still 2. These are just two different ways of writing it. One as a radical, one as a rational exponent. Okay? All right. Now, these directions say, first of all, we can't figure out what it equals because we don't know what x is, right? Okay, so the directions tell us rewrite each using a rational exponent. So we need to rewrite this, but instead of having a radical, having a rational exponent. So how could we rewrite the square root of x, but with a rational exponent instead? What power did we always have? It was the same as square root. 1/2, right? Because this has an exponent of 1, and this has a 2 out here. So we could rewrite this as x to the 1/2 power. Okay, try the next one. Okay, so how would you rewrite square root of y? Y to the 1/2 power. Good. Okay. How about the square root of x to the 3rd power? Mind you, if there's not a root there, it's a 2. Kiana?
It'd be x to the 3/2 power.
Good. X to the 3/2 power. X raised to the 3/2. Don't turn it to a mixed number. Leave it as a ratio. Doesn't matter that it looks improper. That's okay. Okay. How about this one? The next one.
X to the 4th power.
Okay, start with writing it using the numbers, and then yes, you are right. X to the 8/2, but then Kiana noticed, well, that 8/2 is 4, so really we should write x to the 4th power, which is correct. You see that? 8 divided by 2 is 4. Okay, very good. All right, so this one is going to start out with x to the 4/2, which is really, we don't say x2. X squared, or x to the 2nd power. Bless you. Okay, the next one would be y to the 8/3, or 8/3 power. The next one would be x to the 8/4, which would then be x squared, right? And y to the 12/5. Those are easy. There's not really much to do there. You have to know that the numerator comes from the power and the denominator comes from the root. If it's square root, then you use 2. Otherwise, it'll tell you, is it the cube root, the 4th root, the 5th root, the 10th root, and that gives you the denominator. Okay, so here, let's do this one. So x to the 6/2 would be x to the 3rd power. Y to the 10th/2 is y to the 5th power. Very good. Okay, the next one, this is x to the 1st power over 3. So x to the 1/3 power, y to the 7/3 power. Okay, the next one, x to the 6/4, which is then 3/2, right? 6/4 simplifies to 3/2.
Yes.
And y to the 4/4, which is just 1, right? Which is just y. We don't need to put 1. Nicholas.
On our homework, when it says it should have
The root?
Yeah, the root. If it's if there's nothing there, can you just divide everything by 2?
Well, it's a 2 if you don't see one, so that's what you would be doing, yes. Yep. Okay, now we're going to rewrite each using a radical. Okay, so remember, this was the power, and this is the type of radical that you have. So it's a square root. So square root, and then x to the third power. We're just working backwards. Okay? This one right here is a 5th root. So we put a little 5, and then we put our radical. So the 5th root of x squared. What's the next root?
2.
Which means it's just square root, so we don't have to put the 2. X to the 9. Next one?
3.
So that's cube root of x to the 7. Good. Very good. Okay. Notice, because we've got more than one variable, double check that they both have the same root. If we're going to put them together under here, we need to make sure they have the same root. Okay, well, they're both square roots. So x to the 7, y to the 3rd. Okay, the next one, what type of root do we have? Cubed root, and then x to the 2nd, y to the 8th. Next one? 5th root of x,
Y to the 8th.
and y to the 8th. Very good. All right, find the value of each without a calculator. Okay, I think it might be easier if you turn it into a radical. It would be easier for you to understand. So let's go ahead and rewrite this as 4 to the 3rd power, and then it's square root of that, correct? Okay, so 4 times 4 times 4, and then we're going to take the square root of it. 4 times 4 is 16, times 4 again is 64. So we have the square root of 64, right? Because 4 times 4 times 4 is 64, and then the square root of 64, yes, is 8. So your answer is just 8. Okay, let's do the same thing with the next one. We have 8 squared inside, but then it's the cubed root. So this would be cubed root of 64. 4 times 4 times 4 is 64. Okay, so the answer is just 4. All right, this one is the 5th root of 32 to the 1st power, which is just 32. So a number times itself 5 times. Not times 5, but something times itself again, times itself again, times itself again. That's 32. Let's try 2. 2 times 2 is 4, times 2 again, 8, times 2 again, 16, times 2 again is 32. So yes, the 5th root of 32 is just 2. All right, now this one, let's rewrite it. This is the 5th root of 32 cubed. Now, we're not using a calculator, so this could get ugly, right? 32 times 32 times 32. And then to go back and try and figure out what number times itself 5 times is going to give me that. Okay, let me show you another option. So you can take it to the power and then find the root, or you can take the root of the number first and then raise it to the power. So you can do it that way too. And this is going to be easier with these larger numbers. So the 5th root of 32, we already figured out is what? Is 2, right? So then we can figure out 2 to the 3rd power. That's much easier, which is 8. Do you see how you can do that? So you can either raise it to the power and then find the root, or you can find the root and then raise it to the power. Okay, so let's look at this next one. This is the 4th root of 16 cubed. All right, I don't want to figure out 16 times 16 times 16, so I'm going to rewrite this. I'm going to figure out the 4th root of 16 first, and then I'm going to cube it. What's the 4th root of 16? 2. 2 times 2 times 2 times 2 is 16. So 2 to the 3rd power, we already figured that out as 8. Okay, same thing here. Cube root of 27. I'm going to go ahead and say I don't want to do 27 times 27, so I'm going to raise it to the power last. So what's the cube root of 27? 9 times 9 times 9 would be 27. 3 times 3 times 3 is 27. Okay, so it's 3, but then raise it to the second power. Oh, you were plugging in the answer, which is what? 9. There you go. Is that the last one?
Yes.